So today I'd like to just kind of walk through how to optimize AI infrastructure, what to think about when you think about AI infrastructure. And of course, we're not going to talk a ton about generative AI, although I'm sure people are thinking quite a bit about it, but clearly that uses the AI infrastructure, and I can talk a little bit about that as we go. So let's start off with the infrastructure that's required in order to be able to run AI. And so in a lot of ways, people think about AI just as a capability and not really think too much about what do I need in order to be able to leverage those capabilities. So I want to talk a little bit about what that infrastructure would look like and then how to optimize it, and then also how to take advantage of the cloud, Microsoft Azure, and other cloud platforms that you would use in order to be able to make your life simpler as you think about what is it that you really need in order to take advantage of these capabilities, especially around generative AI and other AI capabilities. So I like to talk about it in terms of these three primary areas. So the first one really focuses on compute. So in order to be able to process your models, in order to be able to serve your models, or to even be able to ask questions and make decisions by using AI capabilities, we need some kind of a computing infrastructure in order to be able to do it. So where are you going to get that? And we're all familiar with do I need to get a server? Do I run it on my local environment? Do I need scalability, et cetera? And I'll talk about some of these things as we go. But compute is super important in terms of thinking about how we can address the compute characteristics of AI models and AI capabilities. The other thing that I'll mention as we go through this is that I'm using the term AI interchangeably with machine learning. So you might say, well, do you mean AI or machine learning? And in this context, I kind of mean both. I'm not going to draw the distinction too heavily today in terms of what that difference is, but there's a slight difference, but in general, we can kind of talk about them in the same way. The second one, and this is super critical as well, is data. So your models or the decisions that you make with any AI capability is only as good as the data that you have. So we want to talk about where do I put my data? How do I store my data? How much do I need? How do I cleanse it? How do I manage it, et cetera? So that's a really important part of the overall capability of the AI infrastructure. So there's a big I'll talk about what some of those characteristics are as well when we get into this, but there's a big complicated governance scenario that focuses around data that we'll also talk about. And so you have to be able to have access to your data and then be able to understand what the data is telling you. And that's part of the process, which leads me into then the software. So which software do you use in terms of being able to not only maximize your AI capabilities or decision-making processes, but also cleaning and refining your data so that it is of sufficient quality, so that it can answer the questions that you are looking to have answered by the data assets that you have. And then also getting into things like responsible AI. What data may be private? How do I protect that data? How do I understand whether or not I have bias in my information? So that's where software comes into play. So all those things together allow us to be able to solve the AI ML problem in terms of being able to leverage that capability to drive our business forward. And we can think about driving our business forward in a couple different ways. We can think about it in the context of increasing our competitive advantage. We can think about it in terms of increasing our operational efficiency, or we can even think about it in terms of just being able to leverage the assets that we have internally in order to be able to make the experience better for our customers and to continue to drive maybe the competitive advantage we already have within our industry. Now at the bottom, and I don't by any means mean to talk about these things as being secondary, but certainly within the infrastructure, we need to layer in security and compliance, monitoring, logging, and then model deployment and serving, which are all part of the process. And I could talk for hours probably about this, but I wanted to give you just some of the characteristics that are associated with the infrastructure components and some things you might want to think about before we have some coffee. So here, how do we determine whether or not we have sufficient computing power? So you might say, well, I've got a big model, I'm trying to accomplish a big thing, and I'll use generative AI just as an example. So we know that in some cases, the first versions of ChatGPT, for example, took as long as a month to train the data in order to be able to release the first large language model, because there are millions of or billions potentially of parameters that are being used as part of the model. And it takes a lot of computing power to be able to do it. And so in order to be able to understand the complexity of that is really the beginning part of where you start. So if you can say the model is complex, or you understand the complexity of the model, then you can start to get a feel for how much computing power do I need in order to make this happen. Because one of the things that we've learned in the cloud was that if in the data center example, when we moved to the cloud, we had this concept of elasticity, or virtualization allowed us to be able to create an elastic environment where we could get additional compute or additional resources as they were required. So we want to think about that as well. Do we need elasticity? Do we not? Is the kind of problem that you're trying to solve, is it relatively stable and straightforward? And if it is, then maybe you can purchase capital equipment and you can purchase the compute power that you might need in order to be able to solve your particular problem. But in cases where it's more unknown, you want to be able to understand what kinds of scalability do you have or can you have in order to optimize your use of these platforms, maximize the value of your data, but also pay for what you use, because you want to ensure that you're not overpaying for potential, compute power that you will never use. So that's really an important characteristic as we think through this. So the other thing that's important to understand, and I'll get into the different types in just a minute, is the type of computing power that we use. GPUs are super popular today. They're more general purpose, especially as it relates to machine learning and to high performance computing. But there's also tensor processing units, or TPUs, and then general CPUs as well, which are not really targeted toward the machine learning environments or models, but they are good for more general purpose computing kinds of activities. So you need to really think about what kind of compute do you need, and again, hitting toward this optimization. So is it that you need GPUs in order to optimize the process flow or the time it takes to create your model and the efficacy of it? Or is it something where you can use more general purpose capabilities, for example? So here, we really just want to understand in a little bit more detail how computationally intensive or what kind of parallel processing algorithms should take advantage or can take advantage of some of these specialized type compute. And deep learning, reinforcement learning, generative adversarial networks, which are popular today, can take advantage of these advanced capabilities in compute. And the other thing that I'll talk just a little bit about is deep learning algorithms. So in this particular case, things that can be parallelized, or artificial neural networks, will also take advantage of these specialized compute capabilities. And if you think about it within Azure or in the cloud, you will see you have the ability to select these kinds of specialized processing units in order to be able to run your workload. So it's something to take into consideration as you think through what is most appropriate, the compute environment that is, for what I'm trying to accomplish. So here I just kind of go through just a simple definition, super high level, of what the difference really is. But in general, it's more use case specific. And so we all know CPUs. We have them in our laptops, and we use them all the time. We think about that as sort of the common mechanism. And typically when we think about computing power, we think about Moore's law, especially as it relates to the CPU. But they're general purpose processors, which are optimized for typically single-threaded performance. Now, I just talked a lot about the fact that these machine learning environments typically use parallel processing, and they have advanced algorithms that we may require additional compute capabilities in a more parallelizable way. So this is where the GPU and the TPU come into play, especially around the AI platforms that we're thinking of. So these are specialized for very particular types of use cases. So the GPU, for example, would be well suited for deep learning or other compute intensive applications. And it's a little bit more versatile than a TPU, which I'll get to in a second. But in general, the GPU usually becomes the workhorse as we think about it today, of the machine learning or the AI algorithmic training and also serving models. So we typically think of the GPU today. However, the TPUs are specialized processors which are really good at specifically machine learning workloads, especially large large-scale deep learning tasks. And so deep learning, which is really the ANNs or adversarial neural networks, can typically perform better with a TPU. So you really do have to understand the distinction based on the type of workload that you want to be able to run. So that's one point that I'll have you walk away with. Think about what is the most appropriate specialized compute that might be important for your particular environment. Now, the other thing that I talked about was planning for scalability. So if you think about, you might say have solved a problem with an algorithm that worked really well in your current environment, but you may need to think about, well, what happens over time? What happens as we scale? We have more data. We have to maybe train a more sophisticated model. So once you get to that point, then you have to think about some of the characteristics that I've listed here. And I'll kind of leave it at a super high level, but basically, the more that you can create a modular design, the more you can sort of compartmentalize the compute capability. And then you can actually sort of, if you will, you can solve the problem in pieces. So that's one way to think about it. Making sure that you're using the right technology stack. So making sure that you have the appropriate set of capabilities, and I'll talk about auto scaling in just a second, that allows you to be able to scale effectively. So that if you're running in the cloud, for example, you can take advantage of the highly virtualized capabilities, or I'll call it elastic environment, in order to be able to scale on demand, which is really important for you as you think about training your particular model. Because as a data scientist, nothing is worse than starting to train a model and then all of a sudden saying, oops, ran out of resources, go back to ground zero. That is a very disheartening thing to see. The other thing that's really important in this environment is to monitor. So know what kind of capacity that you are using and that you might need in the future. So that's really critical as well, because anytime that you want to think about things like auto scalability, well, you want to understand how much am I actually using? When do I want to trigger the expansion event, if you will, in order to be able to add more computing capabilities? And then, of course, everybody's talking about microservices and containers and scalability from the container level. It's really just a smart thing to do in the grand scheme of things. And I know it's not really compute specific, but the more that we can create sort of the modular design model and then be able to take our containers and scale them across multiple processor environments or clusters, the easier it's going to be for us to support the scalability model that we might want to take advantage of. So just things to take into consideration. Now, shifting to data just a little bit. So I talked about data as being sort of the lifeblood of what it is that we're looking to accomplish. Because any model, no matter how fast the compute or how effective the model might be, it's only as good as your data. So on the data storage side, we want to think about things like scalability, performance, how many IOPS can I get out of that particular data? How can I feed the training algorithm effectively so that I can take advantage of that CPU that I might have available to me? And we also want to think about reliability and security of that data. So as much as we might want to just say, all I need is raw IOPS in order to get the data as quickly as possible, we also have to think about, well, what's happening on the security side? Can I protect that data? And do I want to make sure that I can include things like the governance of that data? For example, things like provenance. Do I know where the data came from? Do I know some of its characteristics? Do I know the lineage of that data as well? So governance becomes an important part as we think about the data itself. And over time, as we start thinking about things like privacy and security and compliance, we may be asked in the data infrastructure to be able to explain how did you come about with that recommendation, or explainability in the AI sense. So what does that really mean in terms of how are you going to tell a regulator or an auditor how you were able to arrive at a particular result? Well, you have to go all the way back to the data asset and apply the algorithm. So these are important characteristics of understanding where the data is, where the data came from, how you're using the data, and then also have some semblance of the quality of that information. How can you rate the quality of the information that you might have, and then determine, I love this term, fit for purpose, what is the fit for purpose as it relates to your problem you're trying to solve or the AI ML algorithm that you're using in order to be able to solve a business problem. And that's really critical to thinking about it. Now, sort of jumping into software considerations. So now I've described sort of compute as well as the data. Now the third area to contemplate is software. So we talked about the specialized processing environment, and then we talked about ways to curate or manage our data assets. Now we have to also think about, well, if I want to be able to maximize the use of, say, a GPU or a TPU, or even a CPU for that matter, do I have the ability to understand how to maximize the benefit of each one of those specialized processors? Well, the answer probably is no. So we need to use frameworks that allow us to be able to take advantage of the fact that I may have GPU capacity in order to run my algorithm in a more parallel way. So frameworks allow us to be able to do that effectively. So the frameworks can be targeted toward particular types of specialized CPUs that allow you to take advantage of those specialized compute capacity that you have available to you and to optimize your performance in order to get you to the result faster, and also to take advantage of the fact that if it's something you're willing to pay for these specialized environments, then you want to make sure that you're using them for benefit, and that really the frameworks actually allow you to be able to do that. So making sure you select the right framework that allows you to be able to run on those specialized environments becomes a really critical component of the overall solution set for you. Databases and data access is another important part of that. So we talked about the data and the storage of the data, but having access to it's another important part of this. So where you put it, enable yourself to be able to access it at speed or at scale is really a critical component as well. So as much as you might say, I have 10 terabytes, I have a petabyte of data, in order to be able to run your algorithm to take advantage of that and run it in a parallel way, you somehow have to be able to access that data with speed. And that really allows you to then be able to say, well, what kinds of data environments do I need in order to be able to do that? And so that's where we get into this concept of which database would you use in order to represent that data so that you can maximize it. That's part of the software platform or framework that you're going to use in order to help you to optimize the performance of your overall environment. I've already talked about cloud compute and the fact that, Azure will allow you to be able to create an infrastructure that's highly elastic. And so you can gain elasticity benefits by saying, I need to burst to a particular set of performance that allows me to be able to run my algorithm, but I don't need it all the time. So I'm only going to do it when I'm training my model. So that allows you to be able to then sort of pay for what you use, which is really one of the huge benefits of using cloud compute. And then security, of course, we already talked about, and operating system may be important to you as well. But in general, these are the software considerations that you would think about in terms of what you pay for, not only, but also then how are you going to be able to maximize the benefit to you as you undertake your AI program or look to innovate by using AI capabilities. And many of these things, we don't typically think about the underlying platform as we think about how it is that we leverage AI. In most cases, we get caught up with the shiny object and say, oh, we definitely need to, start doing generative AI, or we need to start using AI to be able to answer all of our questions for us. But we don't really think about what goes behind it. And that's really what we're talking about today. So what does the infrastructure need to look like in order to be able to provide these capabilities for you as an organization? So the next thing I'll talk about is like, how do you optimize, or what's machine learning framework optimization? So one of the important things is, and this really is a matter of understanding the problem domain that you're in. So what type of machine learning problem are you trying to solve? So if you're trying to solve problems which are more related to, let's just say, things that maybe are more associated with machine learning versus sort of artificial intelligence, and machine learning, I mean more probabilistic kinds of models, then there are certain frameworks that will help you to create machine learning type algorithms more effectively. For example, TensorFlow, scikit-learn are two different ways that you can do this. If you're doing things that are more, say, large language model or reinforcement learning, generative style, deep learning algorithms, there are other platforms that might be more beneficial that would allow you to be able to do this more effectively. So you kind of have to think about what problem you're trying to solve first before you can really jump into selecting the hardware software as well as the framework. So first start with that as what it is you're trying to achieve. The programming language will be important as well. So now there are, in many cases, and I'll use ChatGPT as a good example of this. Well, it's more of a SaaS tool. So basically, it's a software as a service. You just use it. You don't have to program the model. You didn't have to write the algorithm. You don't even have to train the data. You're just using it. But in many cases, you may actually look at a scenario where we want to create our own models. We want to be able to write our own code. We want to be able to train our own data and curate our own data assets. So those languages may be important to you. So you would think about the framework from the perspective of which language might be most appropriate for either the talent that you have internally within your organization, or maybe the ones where you want to train people. For example, Python's one of the more popular data science languages. Maybe it's easy for people to learn Python and start using Python as your primary language as you think about how are you going to create a programming environment for what you do. And then size and complexity of your data set, another important one in terms of framework. So how much variability do you have in that data set? How much do you need to stitch things together? And then we can even get into things like MLOps pipelines, which help us to understand where does the data come from? How do I process that data in order to make it ready for AI capabilities? And then how do I create an operational platform or perspective in order to be able to do this repeatedly? Because if you have agility then in your framework, it allows you to be able to hypothesize, test, and go back and forth, which is one of the biggest parts of the whole data science lifecycle. You don't always get it right the first time, but you do have the ability to repeat. And so by leveraging frameworks, it allows you to be able to do that effectively. And then budget is always a big thing as well. So depending on how much budget you have, you can leverage existing frameworks, which are available out there today, or you can use open source tools, or you can use tools that are provided to you by, for example, within the Azure platform. There are frameworks that make it really easy for you to be able to implement your overall framework and then allow you to be able to just answer those business questions that you're trying to answer without going through a lot of programming. That's a key way to actually move it in the right direction or get going fast. So you don't have to hire a group of PhD data scientists. You don't have to find expert Python programmers. You can leverage capabilities that are available in the cloud, which allow you to get up to speed and run quickly. And there are even AutoML techniques, which allow you to be able to do it fast. So again, it really just has to do with which framework it most represents the kind of thing that you're trying to achieve, but also it focuses on what capabilities do you want to support moving forward. And then finally, frameworks have large active communities that you might want to take advantage of. And especially today, I've seen probably hundreds of posts in the last week or so about large language models, how they work, how you can run them locally. So lots of people are testing and getting involved in the community to be able to talk about how you can learn more about specific types of techniques that might be most applicable for what it is you're looking to do. Okay, and then so finally, if we talk about cloud or on-premise, I already alluded to some of these, so I'm not going to spend a ton of time here. But basically, it has to do with cost, performance, the security, and the features that you might want to look for, and then what kind of support are you expecting. And if you can think about it in the context of, are you looking for IaaS models, PaaS models, or SaaS models? And cloud providers like Microsoft can provide you with all three. So basically, depending on what it is that you want to do, you can actually leverage the platform integrations that are already available in a PaaS or SaaS offering, or you can do your own, if you will, by using IaaS, and then also doing on premises if that's the inclination that you want to take in terms of being able to support the environment. And then just finally, the optimization and ROI is an important part. So customers ask me a lot, what do we do in terms of understanding how much value? So I talked a lot about the potential cost of these things. Well, you have to make sure that there is some kind of asset realization. So you want to make sure, is there some value that's coming out of this? And then how do I depict it?